this is Eva Amson, welcoming you to this Bite-Size Bio webinar, which today is sponsored by Eppendorf. Eppendorf is a leading life science company that develops and sells systems for use in laboratories worldwide. Divided into the business units liquid handling, consumables, separation and instrumentation, bioprocess and workflow solutions, the product portfolio includes pipettes, pipette tips, centrifuges, mixers, and ultra-low temperature equipment. In addition, Eppendorf offers a wide range of high-quality consumables. Today's presentation is titled Level Up Your Pipetting, and it's being presented by Hamid Haidari and Maren Rudolph from Eppendorf. Hamid has worked for Eppendorf in various application, sales, and marketing roles for over 20 years, and is now Product Marketing Manager for manual liquid handling. In his current position, one of his main goals is to find the right liquid handling solution for each customer. For several years, customers throughout Europe have benefited from his many years of experience in manual liquid handling through his pipetting training courses and workshops. Before working for Eppendorf, he studied biology at the University of Vienna and holds a PhD in molecular immunobiology with a focus on signal transduction. Maren is an application specialist focusing on manual liquid handling at Eppendorf in Hamburg, Germany. Since joining Eppendorf in February 2022, she has been responsible for applications of liquid handling systems and training. She holds a PhD from the Institute of Medical Microbiology, Virology and Hygiene in Hamburg, Germany, where her research focused on visualizing bacterial proteins during host cell infection. As always, we will have a question and answer session after the presentation. So please type any questions you have into the questions box, which appears on the top right panel of your screen, and I'll put them to Hamid and Maren at the end. Details of how to access the on-demand recording of this webinar will be sent to you by email shortly. So now over to you, Hamid, for the presentation.
Hello and a warm welcome from my side. So let's start by having a look at the agenda for today. After a short introduction into the topics, I will talk about the different aspects to consider how to level up your pipetting and which tools you might need to achieve it. And at the end of the presentation, we'll have a live demo. Stay tuned. Do you know which factors influence the pipetting accuracy? There are several factors affecting pipetting results. From pipette itself, user, environment, the type of liquid, to the pipettes, there are many factors. However, let's focus on the pipettes in this case, as this is our focus topic today. While the pipette accuracy is definitely one of the most important factors, which is highly depending on the pipette conditions. For instance, if the pipette is calibrated, if the pipette is maintained or serviced, choosing the right pipette for a specific application or a certain volume, it is particularly about the air cushion size. And well, depending on the liquid volume we would like to transfer, too big or too small air cushion size might affect the pipetting accuracy. Shall we use an electronic or mechanical pipette, which is depending on the number of samples and liquid type? Which pipette suits better, a single channel or a multi-channel, depending on the type of the vessel we are planning to use and more. Knowing the right pipetting principle is important. Which pipette principle is the proper one for my experiment? For aqueous liquid type, an air cushion pipette is a good choice. However, in case you are dealing with difficult or challenging liquid, positive displacement systems are the best. Well, lack of this knowledge can have consequently a significant effect on pipetting results. But what do you expect from a pipette? It is obvious that a pipette should fulfill a minimum of basic requirement. It should ensure the accuracy and the reproducibility of the results. It's supposed to be intuitive and easy to use. Last but not least, a low fast operation, meaning easy to setting and programming. What do you think? Which type of pipette could fulfill these requirements? An electronic one or a mechanical one? Let's have a closer look at the electronic pipettes. Why should you need an electronic pipette? Many people work in the lab for a long time without using an electronic pipette. They are asking, why should I use an electronic pipette? There might be several reasons for this, like the higher price is something a purchase hurdle, never change a running system. I do a good job with my mechanical pipette and I am fast at pipetting. Electronic pipettes perceived as complicated due to the comprehensive features. They don't want to leave their comfort zone as they must undergo a learning curve for electronic pipettes ahead of using them. However, what about if someone tries to reproduce your data, for instance, in another lab somewhere else, or someone wants to pipette in a lab high above the sea level? Or the experiment requires complex pipetting steps with difficult liquids. There should still be correct results, right? You still want a pipette that is easy to use, that produces accurate results independent of the user, the location, or the liquid, and you want it to enable fast work. In the following, I will explain you why it is possible to get this with an electronic pipette and what to look out for when choosing one. What are the advantages of an electronic pipette? Higher precision, especially when pipetting large series. They are multifunctional, multitasking, pipetting, dispensing, mixing, and more. They reduce stress and secure fatigue-free pipetting. They are a perfect tool for pipetting difficult liquids like whiskers, high vapor, etc. And they offer documentation like pipetting history and a lot more. In the following slides, I will highlight the importance of ergonomics regarding the pipetting. How about the ergonomics? A big advantage of electronic pipette is the low operation force. With a mechanical pipette, you have to push the operation button up and down by yourself to move the piston within the pipette, which can become painful after a while. The piston in an electronic pipette is moved by a small motor which you control by just touching a button, which can make your life easier if you must perform many pipetting steps during a day. However, some people would be afraid that the electronic pipettes are less ergonomic, not well balanced, difficult to operate, or heavier than mechanical pipettes. But this is not necessarily the case. As with electronic pipettes, it remains important that the device is ergonomically designed with easy to reach control buttons and ejector. In addition, the display should be designed in a fashion that is easy to read with regard to the angle, brightness, and setup. With the integrated motor, it is important that the weight is well balanced, with the center of gravity not too high at the top, so it lies well in your hand. If possible, ask for a test of the pipette and check for these features before you're buying it. If designed correctly, an electronic pipette can help you avoid stress of your arms and hands during a busy day in the lab. In general, An electronic pipette should not significantly exceed the weight of a mechanical pipette. So this is also important to be considered as a purchase criteria. Another aspect which is important for stress-free pipetting is an intuitive operating concept. Some people would expect an electronic pipette to be confusing and that you would lose control of the operation. However, an electronic pipette does not have to be difficult to operate. Select a pipette with settings that are well structured and easily understandable to prevent confusion and mistakes. Avoid pipettes with many submenus and hidden features. In addition, you should always be in control of the piston movement so you can stop and continue its movement at any time and control the blowout. This is especially important when it comes to viscous or foaming liquids, where you need additional blowout steps or avoid a blowout to prevent foam formation. An intuitive operation helps you to stay relaxed during your lab work and have permanent control of the pipette functions. Next, we will talk about how electronic pipettes improve reproducibility at different levels. When it comes to reproducibility, one factor which can influence your results is the piston movement. With mechanical pipettes, we are nearly always too fast, depending very much on the users, which can lead to imprecision results. The liquid needs some time to catch up with the piston movement. For inexperienced people, there is even a danger of contamination. The pipette, when releasing the control button too fast, and liquid splashes up on the pipette cone. And it is likely that we use different speeds depending on the day and time. We do the experiment resulting in differences between replicates. With the electronic pipettes, the piston moves smoothly with exact stops and defined speed setting from slow to fast. And this is independent of the user. So no matter who uses it and when, the movement stays the same. In addition, the option to choose a slow movement helps to reduce shear forces during uptake and dispensing of the liquid, which could harm functional units like cells or DNA. Together, these factors help to produce precise and reproducible results, which helps to reduce cost by saving materials and optimize time because it eliminates the need to repeat experiments. With an electronic pipette, we can dramatically reduce to a certain level the source of error, which is the human being, and increase reproducibility. The impact of a motor-operated piston can even be measured when comparing the random error of mechanical and electronic pipettes. Here, we compared 100 microliter, 1000 microliter, and 5000 microliter pipettes and pipetting 10%, 50%, and 100% of their nominal volume. We could measure a reduction of the random error between 15 and 69% when using electronic pipettes. This proves how a motor-controlled piston can improve precision and thereby also reproducibility. How about adjustment to specific physical conditions? In addition to a precisely controlled piston movement, some electronic pipettes can further increase reproducibility by offering convenient adjustment options to different physical conditions of either your surrounding or your sample. Generally speaking, a pipette is calibrated to a specific ambient temperature with a specific air pressure using water. Altering conditions can affect the air cushion between the sample and the piston inside the pipette. Differences in temperature, air pressure, or liquid density influence the air cushion in a way that leads to the aspiration of too much or too little liquid, resulting in inaccurate results. An adjustment option can make up for this. For example, some pipettes can adjust to elongated tips, where a larger air cushion could reduce the pipetting results. There are also options to adjust to different geographic altitudes and ambient pressure. The air pressure decreases at higher altitudes, resulting in the aspiration of too small volumes, which an adjustment can compensate. Furthermore, some pipettes provide the options to automatically adjust to a liquid with different densities than water, such as glycerol or ethanol. In combination with a specific pipetting technique, this will increase the accuracy. Alternatively, it is possible to perform different gravimetric measures of a liquid and use the results to adjust the pipette to the specific properties, such as a very high density liquid. Some of these adjustments are also possible with certain mechanical pipettes, but with electronic pipettes, they can be quickly selected and unselected without using tools or the requirement of a specific training in most cases. Let me ask you a question. How reliable are your pipettes? To guarantee reproducibility over time, some pipettes offer an automatic service interval warning based on time or frequency of use, measured in aspiration and dispensing cycles, reminding you of every maintenance or calibration required. This way, you don't have to worry about forgetting to calibrate your pipette and can easily adhere to possible regulations without difficult bookkeeping. A well-maintained pipette helps you to provide accurate pipetting results throughout its lifetime. In the following, we will talk about how electronic pipettes can help to increase your efficiency in the lab and become faster. Electronic pipettes offers versatile pipetting modes. Apart from the normal transferring of one volume to another vessel, as you would with a normal mechanical pipette, an electronic pipette offers you many different features which allow for complex pipetting. Besides, they can prevent errors such as the wrong volume or losing track of which steps you are at. When using the same pipette model, your results become more independent of the users as you can select the exact same setting. This way, you save time and acquire more reproducible results by reducing the human error. Exemplary operation modes like dispensing, reverse pipetting, pipetting and mixing, programming functions, history functions, helping you to be more accurate, increase reproducibility, and ergonomics. Now it's about how electronic pipettes provides access to digital lab. What is a digital lab? A digital extension of existing product in order to bring pipetting to the next level as a system. Is it possible to evolve an electronic pipette even further? Our answer is yes. Our solution is the Pipette Manager. The Pipette Manager is a touch server to control connected electronic pipettes. Eppendorf Explorer and Explorer Plus, including Move It, can be connected to the Pipette Manager easily. To work in parallel, customary tablets, Androids, or iOS can also be connected to expand the capabilities of the whole system. What are the capabilities of a Pipette Manager? What are the added values of Pipette Manager which can ease your daily work life? The Pipette Manager is a standalone plug-and-play system with no need for internet connectivity. Up to 30 Appendov Explorer or Explorer Plus, including MoveIt or tablets, can be connected to the Pipette Manager for easy setup and programming. Pipetting setting can be entered or changed quickly with just few clicks, easy and securely. The Appendov Liquid Manager will give you guidance around the liquid type. Choose either from the predefined Appendov liquid types or create your own one and share with others if needed. It offers also an automatic documentation of your pipetting steps just by clicking start, and that's it. You can easily pause and switch between several recordings, documented steps. And after finishing the recording, export your recording as uneditable PDF file via USB connections and save or archive it as appropriate. Although there are many advantages for using electronic pipette instead of mechanical one, many people are still not willing to move on and change their system to a more advanced system. There are three main reasons I want to mention here. The operation of an electronic pipette is still perceived as complicated. Due to the wide range of functions and options in combination with a natural given physical limitation in the screen size, some users see this as complex. Of course, electronic pipette seems to be more complex as they accommodate much more features versus mechanical pipettes. To make yourself familiar with the new electronic pipettes and before fully tapped into the potential of electronic pipettes, the user needs to learn the operation, which needs a bit of time. And in some cases, this is a purchase hurdle. However, this is a good investment for the future. Dealing with challenging liquid is always a pain. You need to have the knowledge and experience how to handle difficult liquid when using a mechanical pipette, although this is not the proper tool to handle this type of liquids. Due to the budget restrictions or personal preferences, many researchers use air cushion pipettes to transfer challenging liquids instead of positive displacement system. And without proper technique, this leads to error-prone pipetting, resulting in low accuracy and precision. Pipette Manager with the implemented Liquid Manager will support you to tackle these challenges. With it, handling difficult liquids turn to be easy and simple. Choose the type of the liquid you plan to work with and start pipetting. An assistant will accompany you through all steps and give you hints for a better pipetting results. In case you are working with a liquid which is not listed in here, you can easily create your own liquid type just by clicking on New and adding the requested parameters, and you will be fine. Documentation gaps. Pipetting steps are extremely tedious to document in the lab manually. Detailed documentation of pipetting steps is extremely time-consuming, which makes it nearly impossible to document this manually. Gaps in experiments documentation may lead to overlooking of errors and reproducibility issues later on. With a new feature, pipetting record, documentation is a no-brainer. As default, the Pipette Manager does not start recording of your pipetting steps unless you press New Recording. Multiple recording can be recreated, paused, and continued. You can also switch between several recordings. If recording is no more requested, you can easily finish recording by clicking on a button, Finish Recording. The report can be exported as a PDF file, not editable, with all relevant information and changes to the status of a recording, like pause or continue, and are documented with date and time stamp. Why should you switch to a connected electronic pipette? Among all benefits about the digital system, there are 3 features which I would like to highlight here. Better usability, fast input of volume, speed, operating mode, and liquid type. Better reproducibility, Liquid Manager helps you to handle challenging liquid. Better documentation, record all your pipetting steps. And as a consequence, you will experience stress-free pipetting. There is a virtual tool for you to get familiar with this digital system, which makes you able to experience the features set online and their benefits without the actual device. Please go to www.ependorf.com/pipette-manager-demo. Clickable features demonstrate along 6 missions. Select a pipette set, change the volume, change the speed, change the operating mode, change the liquid type, document your pipetting steps, and you will be fine. So now it's time for the live demo. For this, now I'm handing over to my colleague, Dr. Mara Rudolph. Hand over to you. Thank you so much.
Okay, thanks Amit, and thanks Eva for the kind introduction. And hi everyone from my side. I will start with a live demo now, so you can actually see the device in action, which I think is the best thing about it. Okay, so here you can see I have the device in front of me and I have 3 connected pipettes, and I will guide you through the details of it. So first, if you want to connect a pipette, it's pretty easy. You simply open up the battery compartment and add a Wi-Fi module into it. So below is the battery and here's the Wi-Fi module. You can connect all pipettes produced from 2015 onwards who have an on-off switch, a soft key, and a USB port here. Okay, and you only have to check with the connected pipettes that the software version is up to date. So if you have an older one, you can connect it to your pipette manager or to your computer and simply do an update of the software. So the Wi-Fi option is possible to use. Yeah, in addition, it's also possible to get some more functions, some more operating modes, which you usually don't have with Explorer pipettes. You actually get them the same ones, so the same operating modes as the Explorer Plus versions have. That's quite a nice benefit. In general, you can use the Pipette Manager to define the settings for the pipette using the touch display. And now you can also use it for just recording and documenting all your pipetting steps in detail. How this looks, I will show you now. So how it makes pipetting much more convenient. So let's start with the home screen here. You can see it that you can enter the volume here, the aspiration and the dispensing speed. You can change the liquid type, tip selection, and an operating mode. In addition, you can select different pipette sets. So here you can see the 3 pipettes, which are connected to the Pipette Manager. There can be more connected pipettes, but only the ones I selected in the pipette set will be changed with the settings. If I change some settings here, they will be changed in these pipettes only and not the other ones. Okay, how this looks like, if I enter the 100 microliter, you also get a little bit of a guidance here. So 100 microliter is possible for all 3 pipettes I have here. So this is the 1200 microliter pipette, 1000 microliter pipette, and 100 microliter pipette. You can see if I add some lower value, like 20 microliters, only the lowest pipette is active. If I add a different value, like 900 microliters, you can also see only the larger volume versions are active. So you get help with selecting the right pipette for what you're doing. With the pipetting mode, this looks quite simple, but if you continue with other operating modes, for example, like the pipetting and mix option, the usability becomes more apparent. So you can see, you can define different cycles, so the mixing cycles, you can define the volume with which to mix it. And if we look at a different operating mode, which is even more complex, like sequential dispensing, you can see the advantage even more apparent. So here you can see that it's a nice advantage to have this nice overview here, so you can much faster enter all the volumes, and in addition you can spot errors, which is more complex if you do it on a pipette itself. And in addition, here you can see it's quite nice that you get the guidance which pipette to use, because usually you would have to add those values up and see if it's possible to be done with the pipette version you're using. So for example, these 6 values which are active now can only be used with a 1200 microliter pipette. If I change it to 5 values, so just the first 5 here are gonna be dispensed, then both pipettes, so of the larger versions, can be used. So yeah, you get some guidance with this. Okay, now we go back to the normal pipetting mode and to the next exciting thing, which is the liquid type. So Eppendorf has some predefined liquid types which you can select from. For example, if we choose a viscous liquid type, 3 things happen. So first you have the pipetting assistants telling you to wait for full aspiration. So if a liquid is viscous, it moves slowly, so it helps if you wait until it's properly aspirated, so you get this little reminder. In addition, the speed is set to automatic here. So the Pipette Manager calculates the required speed for each pipette version. So if you have a 1000 microliter version, the speed is different than a 100 microliter version. So this happens automatically. And the third thing which is happening is that unsuitable operating modes are disabled. So for example, before we were in the pipetting mode, and now it's switched automatically to reverse pipetting, which helps to produce better pipetting results for viscous liquids. Now let's have a look at the other liquid type, acetone. Select acetone. Here 2 things happen. So first you get a notification that pre-wetting is going to happen. Pre-wetting is only pipetting up and down a liquid before transferring it. This is necessary for volatile liquids because they have a higher vapor pressure, and with a high vapor pressure the liquid can evaporate, the air cushion expands, and it will push the liquid out of the pipette tip. I think if you've seen it in a lab before, if some liquid was dripping out of your pipette tip, it is possible that it was a volatile liquid like ethanol, methanol, acetone, because there the vapor pressure is quite high. And this can be quite annoying if you're working with some compound which contains a volatile liquid. But now we want to see how this looks like. So first I'm going to show you how it looks like with a mechanic pipette. I have a Research Plus here. And if we don't have the liquid type, I have some nail polish remover containing acetone, and I will take up this liquid without the liquid type, just taking it up, and I can show you how the liquid is dripping out of the pipette tip. I hope you can see it. So I'm losing quite a bit if I'm not really fast at pipetting. So put it back into the tube, and now we do the comparison with the liquid type. Okay, I select, let's go back to the pipetting mode. Let's select 1000 microliters. Okay, I select the 1000 microliter pipette, take up a tip, and try to find a position so you can see it properly. Okay, so if I'm aspirating, you see that one pre-wetting step was performed before the liquid was taken up. And you can also see that no liquid is dripping out of the pipette tip anymore. So just one pre-wetting step was enough here. But I can also show you if I put the liquid back in, discard the pipette tip, and place the pipette back so you can see it, that if I now change the volume, also the number of pre-wetting steps will change. So if I go to 950 microliters, for example, and now I just pretend to pipette, but I press aspirate, you can see, have a look at the display, you can see that the display will show you how many pre-wetting steps will be performed. So here you see 3 pre-wetting steps are performed before you can dispense liquid again. Yeah, so this shows that the pipette manager calculates how many pre-wetting steps are required based on the volume you chose, but also on the air cushion above the volume. So this is in relation, and here it's important to select the right number of pre-wetting steps to get best results. But just in case you don't want to rely on the Eppendorf predefined liquid types, we have an option under menu. You can go to the liquid manager and define your own liquid type. So just select new, and there you have different options. For example, volatile liquids, you can select different vapor pressures. Viscous liquids, you can select liquids of different dynamic viscosity. Or if you want to do a customized version, you can select either individual pre-wetting steps or automatic pre-wetting steps. And you can select the required pipetting speed. So you can just optimize depending also on the requirement, how precise your pipetting results need to be. You can just define it yourself and save it, share it with your colleagues, and make your pipetting results much more reproducible. I will enter the, leave it now, okay. Okay, so now let's come to the new feature, our pipetting records. So if you want to start the pipetting record, you only click on new recording. We give it a title, whatever suits your application. We call it obviously the VIP experiment. It's very important. Okay. You simply confirm it and start the recording. Now you can see with the recording badge up here that the recording is active. So you have this green badge up here if an active recording is going on. So now we simply perform one pipetting step. I select aqueous liquid types and pipetting mode 950 microliters, and I click on aspirate and dispense. And now this was a normal pipetting step I performed. Now I want to show you what happens if I perform an error. So I slowed down the aspiration speed for this, so I can show it better. If I take the pipette and I aspirate, and then I pretend to make a mistake and I eject the tip during aspiration. So obviously that wasn't what I wanted to do. So this was an error, and we can have a look how this looks like in our recording. So both steps have been recorded, and we can access them over the Open Recordings menu here. If you click on the recording badge, you come to this menu, and you have 3 different recordings types you can look at. So you have the active recording, the one we just started. Then we have the pause recordings, which you started previously, and there are also remote recordings. The pause recordings you can access by going on switch recording. So if you want to continue a recording for a different experiment, you could say switch recording now and continue this one. And from different accounts, you can claim also this recording and continue it, but only if you're an admin, this is possible. If you're not an admin, then you can't claim it. If you want to have a look at our experiment right now, we go on about this recording and see all the details here. So we have the title, the start date, the associated pipettes. Here I only used 1 pipette so far. And down here we have the events. If we want to have a closer look at the events, we open them. So far 3 events were recorded. So first that I started the recording, that was the first event. Then the second event is the first pipetting step I performed, which I performed correctly. So we have the pipette serial number, the volume, the pipetting mode, the liquid type, and the speed. If we have a look at the other event where I pretended that I made a mistake, you can have a look. Same things are recorded, but you have the notification tip ejected during pipetting operation. So you see if you have an error during pipetting, this will be recorded, so no errors are lost. If you go back to the home screen, you can see that you can also say pause recording and select work without recording if you want to do something else which you don't want to record at the moment. Then you can also see the recording badge up here went from green to white, so it's not recorded anymore. If you want to continue your recording, simply press continue recording down here and select continue, and you can continue with your experiment. If you decide that you're finished with your recording, you can select finish recording and select finish and log. So that means you can't continue this experiment anymore, but you can export it. So I finish this experiment, get the notification, and under menu, I find the pipetting records here. So all the finished records are down here. And if I select our experiment, I can go on the export button here in the upper corner. I have a USB stick in the back of the device and can say confirm, and it's exported as a PDF document. Perfect. Okay, so this was the demo of the new feature today. And if you want to see this for yourself, you can also try out our demo tool, which Hamid mentioned. So this is a very nice option just to go through all the functions by yourself. Okay, thank you for today. And I'm curious what your questions will be.
Thank you, Maren, for an excellent demonstration and an interesting presentation from Hamid before that. We have a few questions from the audience. If anyone else has a question, please feel free to post it in the questions box that appears on the top right of your screen. So the first question I've got, Maren, this is for you. What is meant by individual adjustments of the pipette?
That is a good question. Actually, many people don't know about it, and that's why they don't use it. So this individual adjustment, Hamid mentioned it in his presentation. So here you have the option to adjust to liquids which have different properties than water. So for example, if you have a liquid which has a higher density, your pipetting results will be incorrect. And if you want to adjust to that, it is possible to perform measurements. And if you enter these measurements into the Explorer pipette in combination with the density value, you can let the pipette automatically adjust to this liquid. So measurement means that you actually measure the weight of the dispensed volume. And if you perform this several times, you have an average value you can enter, and together with the density, the pipette can calculate that you actually dispense the correct amount. And we call it, so you have different options, so either 1-point adjustment, 2-point adjustment, or 3-point adjustment. And like it sounds, so you have the option to either just enter the value for one volume you dispensed with your pipette, or the volume of 3 different points. So like, I don't know, 10%, 50%, and 100%, like for a calibration. If you enter those 3 points, you get the best adjustment and the best results, even with liquids which are not like water. So that's what this is all about.
Great, thank you. And a question for Hamid. Are the electronic pipettes more sustainable?
Well, a very good question, actually. Absolutely, I would say. Sustainability is not about saving plastic only. Other aspects like ergonomics, reproducibility, etc., are indispensable if you would like to increase sustainability in your app. While you increase the reproducibility of your results by using an electronic pipette, at the same time you reduce the material like lab consumables, reagents, and chemicals, and therefore reduce the waste. Furthermore, by choosing an electronic pipette, you can save time, resources, and finally money. All these are possible just by reducing the effect of human factor by using an electronic pipette.
That makes sense. Thank you. I've got another question for you, Hamid. When you're using the electronic pipette, can an error in calibration be corrected?
Well, this is a very interesting question. So, well, it depends on the type of error. Caused through external parameters or the pipette itself. Obviously, the pipette is not able to be calibrated on its own. If you mean using the pipette under different conditions that your pipette has been calibrated, the answer is definitely yes. If we talk about the different altitudes or using other type of liquids like ethanol, adjustment can help to readjust the pipette to the new environmental conditions. Just go to the setting and change the parameters and you will be fine.
Thanks. Maren, can you write programs on the Pipetting Manager?
So you can write programs on the Explorer pipettes, so small programs, so can combine different operating modes. For the Pipette Manager, it's not possible so far, but we plan many extensions in the future for the Pipette Manager, so we call it the release train. So there will be more and more features coming up. So we listen to the customer what they want and see what is possible. So that's what I can say so far.
Thanks. And Hamid, which information can be documented using the Pipette Manager?
I can take over. So with the Pipette Manager, you can document, for example, the operating mode you are using, including the volume and the pipetting speed, so aspiration and dispensing speed. You can document the liquid type you were using, but also like if it's a more complex operating mode, it's not just the volume which is recorded, but for example, also mixing cycles. And it's also possible, like I showed you in the demo, that you can simply also record errors. I think that's probably one thing we all want to know if we did something wrong. So then we definitely need to document these points or check if there was an error in the pipetting.
That makes sense. Thanks. I think Hamid is still frozen. So
yeah.
I've got one more question for you. Let me see, unless something else has come in. Oh, we do just have a new question. Actually, this is quite related to what I was going to ask you, so I'll just ask this question. Sometimes we need in and out pipetting steps to wash or mix a difficult solute to a solvent. Can electronic pipetting help in such cases?
Yeah, that's actually a very good question. So that's one popular option you can use the electronic pipettes for. So you can define on the Pipette Manager or also on the electronic pipette itself that you have mixing cycles. So you can define the number of mixing cycles, but also the volume you want to mix with. So that is possible and quite useful because you don't have to pipette up and down yourself. If you have to do it the whole day, it can get quite annoying. So if the pipette can do it for you, it's quite nice.
Cool, thank you. So we've reached the end of our questions. I do see that Hamid is back. Hi, welcome back. Just in time for the closing of the webinar. So thank you so much, both of you, for a very interesting presentation and demonstration. And thanks, of course, to our sponsor, Eppendorf. And finally, thanks to you, the audience, for taking the time to attend and listen in. So until next time, good luck in your research, and goodbye from all of us at Eppendorf and Bite Size Bio.